Hello, welcome to Tutors.am, and in this video we're going to be going over a 2017 ECZ past paper. So this is a past paper. So the first question is saying simplify this. So let's just solve the first question. So the first question says 2a minus 7b minus 2, and then here we have a minus 3b. So if we want to simplify this type of question, what do we do first? Notice that we have got brackets here, and can we simplify things that are in the brackets? We can't. So what we are going to do is that we're going to get this negative 2, and then it's going to multiply everything that's in our brackets. So we're going to have a 2a minus 7b, and then what is negative 2 times a? We are going to have negative 2a. Common mistake that people make is multiplying 2 by this instead of multiplying negative 2. You're going to get the 2 with its sign, which is negative, and then we're going to have negative 2 times 3b, that is positive 6b, and then upon reaching this stage we collect our like terms. We're going to have a 2a minus 2a minus 7b plus 6b. So here we know that when we have two different signs we subtract. So 2a minus 2a, that is 0, and then we are going to have a negative 7b plus 6b. So we're going to subtract this and get a sign of bigger number. So 7 minus 6, that is 1. The biggest number is 7, and it has got a b, so we're going to have a minus b. So this minus b is our answer. Now let's go on to question 2. Let's go on to question 2. So question 2 says factorize completely. So this is question 2. It wants us to factorize that expression right there. So how are we going to factorize that expression? What we are simply going to say is the expression is x squared minus 4y squared minus 1 over 9. The only way that we can factorize this is using the difference of two squares. So the square root of x is x, the square root of 4 is 2, the square root of y is y, the square root of 1 is 1, the square root of 9 is 3. So we're going to have that expression right here. Then this whole expression is going to be multiplying the same expression, except we're going to change this plus side to a positive to account for the negative and the positive root. That's all about that one. So we have factorized this one. So let's move on to the next question. Let's move on to the next question, and then we see how we can solve the other question. Let me get back. So my other question is given this matrix times that matrix is equals to that one. Find the value of x. So for this one we're going to find the value of x, and then we're going to prove if our value of x is correct. So our matrix is 2. Here we have got x, here we have got 1, here we have got a negative 5, here we have 4, 3 is equal to 14 and negative 17. So let's say we want to solve this matrix. We want to find the value of x. So these two matrices have been multiplied. So for a matrix to be multiplied, we first check the order of matrix. So this is a 2 by 2. And then this is a 2 by 1. So if a matrix is able to be multiplied, these two have to be the same. After getting an order of matrix, these two have to be the same number, and then the answer will be a 2 by 1, which is this matrix right here. So let's see how we can go about solving that one. So notice, if I multiply this by that, my answer will be a negative 14. So I'm simply going to say 2 times 4. That's how we go about it. Then we have plus, all this is being added to x times 3. So my x, and then this is my times, and then this is my 3. All this should be equal to 14. So this will become 8. So this is 8 plus 3x is equal to 14. So we're going to have 3x is equal to 14 minus 8. 14 minus 8, that is 6 over 6. All this is going to be over 3 over 3. We'll find that our x be equal to 2. So let's prove if what we have done is correct. Let's prove with a matrix. Let's try replacing our matrix with 2 and seeing if that's correct. Let's try that. So if I put in my 2, will it get me back to 14? In fact, we're going to prove for the overall matrix. We're just going to multiply our two matrices, and then we see if what we have found is correct. So notice that we found our x being equal to 2, and then let's see if it gives us this matrix right there. So we said that our x is equal to 2. So sorry for my graphic looking 2. So yeah, now let's multiply. So we're going to have 2 times 4 plus 2 times 3. So I'm going to have 2. Let me just do this. So I'm going to have 2 times 4 plus 2 times 3, close matrix, and then I'm going to have 5 negative 5 times my 4 plus my 1 times my 3. So what do I get? Let me just remove this part. Let me just remove this part and then we get back. So notice that here I'm going to have 8 plus, that is 6, and then here I'm going to have negative 20. I'm going to have a negative 20, and then here I'm going to have a positive 3. So notice that when I add 8 plus 6, that is a 14, which is here. So I have proved. And then when I say negative 20 plus 3, I get a negative 17. So then my answer too was correct. You don't have to show the proving part. That's just if you want to check. But if you're in an exam, you're not given that time to start going through if all your answers are correct. So I'd rather skip that. So let's go to the next question. So the next question says, two things are geometrically similar in the ratio of their volumes. So we have been given the ratio of volumes. Find the ratio of their curved surfaces. How do we go about that? So we have been given the ratio of volumes. So I can just say R ratio of volumes is equal. So ratio of volumes 27 to to 64. So if this is a ratio of volumes, how can we find the ratio of sides? So you have to know that the cube root of the ratio of volumes is equal to the ratio of sides. So if we want to find the ratio of areas, first we have to find the ratio of sides, because our question is asking us to find the ratio of their curved surface area. So this is what we are looking for right here. So this is how I'm going to put it. So I'm going to have my cube root, my ratio of volumes are 27 to 64. So if I cube root this, if I find my cube root of 27, I know that my cube root of 27 is 3. My cube root of 64 is 4. And then notice, if your answers aren't fixed root, you can divide them to its simplest. You can just divide them until you have two numbers that both have cube roots. Yeah. So now that I've gotten my ratio of sides, so ratio of sides, they want me to find my area squared. So your ratio of sides squared is equal to the ratio of areas. So my ratio of sides are 3 to 4. So I'm just going to say 3 to 4 in brackets cube root, or squared, sorry. So if my square of 3 is 9, my square of 4 is 16. So this is my answer. This is equal to my ratio of areas. So that was the answer. So we have done question 4. Let's go on to question 5. Let's do question 5 together. Question 5. Let's see what question 5 requires of us, and then we shall do exactly that it requires. Where is my... So question 5, we have been given vector A in terms of a column vector to 3 and negative 4. So they want us to find the magnitude of A. How can we find our A magnitude? So what I simply do with vectors, this is just me, I first say A, because vector is a very challenging topic, because each year in every past paper they change the way that they bring vector drawings. So vectors are very challenging to a certain extent, but this is a very simple question given to us, so it can be solved easily. So I'm just going to say that my A, sorry, let me just write my A, that my A magnitude is going to be equal to a cube root of my x to the root of x squared plus y squared, sorry. So if this is my way, so I'm just going to replace, and then with vectors, what you have to know is that that your 3 is your x, your 4 is your negative 4 is your y. So my x, I can just represent it as my 3 comma my y is negative 4. So what is my 3 squared? So I'm going to have 3 squared plus y squared, that is negative 4 squared. I'm going to put it in brackets. I have my reasons for putting it in brackets, because when you say negative 4 squared, the answer that you get is negative 16. You can go confirm on your calculators if you do not trust me. And then once you have it in brackets on your calculator, you say squared, this is going to be a 16. Since we are replacing, we are going to put it in brackets. So I just thought you should have that bit of knowledge. I'm sure I even shared it in one of my videos. Yeah, one of my videos. So remember, every time you're replacing, I suggest put it in brackets, so that you don't forget. Eh? Forgetting is the enemy. So this is squared. So my 3 squared, that is my 9. My negative 4 in bracket squared is 16. 9 plus 16, that is 25. The root of 25 is 5. So A magnitude is 5. Let's go on to our next question. And if you know a certain question and how to solve it, you just feel free to pause the video, try out, then press play to see if you have gotten it right. So question 3 is something like this. So it's question 3. I'm sure I'm just going to put my answer here. So for question 3, this is how you go about it. On a Venn diagram, in the on the Venn diagram, in the answer space below, shade the region defined by A complement B union C. So what I do myself is that I put numbers. So here I put my number 1, 2, 3, 4, 5, 6, 7, and my 8 outside. So what I'm going to do is that first I'm going to write my A complement. Is this a very nice place to write? Okay, this is workable. So what are my A complement, meaning the elements that are not in A complement, that are not in A. So 3, 6, 7, and 8 are not in A. So I'm going to have 3, 6, this is quite different, right? 7 and 8. So all these should be intersected, this intersection, with B union C. So what is in B union C? So combine B and C. So if we combine B and C, we'll have 2, 3. Once we combine B and C, 4, we'll have that, because we're getting B and C, and then we'll have 4 there. We'll also have 5, 6, and 7. So now what is in between? So now remember that we have this intersection. So what is this side and that side? What are the common elements in that side? So I'm just going to put this equals to as my final answer to show that my region which I'm going to shade. So I've got 3. So I've got my 3. I've got 4. I've got 4 right there. I've got 7. 7 is also appearing both sides. So I just have to shade the side that has got 3. Oh, sorry, not my 4 does not appear that side, sorry. So that my answer will just be, sorry, mistake, 3, which is here. 6 appears both sides, sorry, 6. And 7 appears both sides, 7. So I'm just going to shade where I've got 3, 6, and 7. Let me just change the color. Let me get gray, and then let me get something very, very thick, just for this one question. So then I'm going to shade this part right here. So this will be my shaded region. My shading is very bad, it's very poor. But otherwise, if you're in an exam standard, you're shading. So remember, the question did not come with numbers, but you can place numbers here to make your work much easier. It's also a technique that I learned way back when I was in grade 9. It was a technique that I found very, very easy to use, and I'm sharing it with you because it's very, very easy. Hats off to the teacher that taught me that. Yeah, so then this is my shaded diagram. So now we can go to this question. So for the sequence 11, 13, 15, 17, find the 13th term. So we have a sequence 11, 13, 15 and 17. And then they want us to find the 13th term. So if we're going to use our formula, Tn is equals to a plus n minus 1 times d, I have to know my d. So my difference is basically 13 minus 11, which is 2, which is also, you can also say 15 minus 13, which is also 2. So I can just say, for those people who are wondering where the 2 came from, this is where it came from. Yeah, so we have our 2. So I can now say Tn is equal to a plus n minus 1 times my difference. So I'm going to say my 13th term is equals to, my a1 is 11 plus the term that I'm trying to find, 13 minus 1, and my common difference, which I've solved for, which is my 2 times 2. So my t of 13 will be equal to 11 plus 13 minus 1, that is 12. 12 times, so we'll have 12 times 2. So my 13th term will be equal to 11 plus 24. So my t of 13 is equivalent to 34. So this is 1, 2, 3, 4. So if you continue adding 2 to 17, and then the next number that you find, you add 2. If you do that 13 times, you're going to get a 34. Let's go on to the next question in our past paper and see how best we can solve it. So the next question is, if the arithmetic mean of 5 and c is 11, find the value of c. So what they have done is that they have found the arithmetic mean. They have said 5 plus c, because these are 2 terms over 2, is equal to 11. So we have to find the value of c. So this is basically how you do this. So I'm going to put this over 1, multiply that side. I'm going to have my 5 plus c, and then I'm going to get a 22, and then my c will be equal to 22 minus 5, which should be a 17 if I'm not mistaken. Yeah, a 17. So this is how we work through that problem. So that when we place this by 5, let me just get out my calculator to confirm, so that if we see what we have done is correct, the calculator. So when we say, first let me just confirm, 22 minus 5, yeah, that's 17. Yeah, that's correct, clear. So that when we say 5 plus 17 over 2, we're going to get back our 11. So I'm in the right track. Yeah, so let's continue solving these questions. So this is going to be our last question, because we are going over 24 minutes. So if this is our transpose matrix, they want us to find our original matrix. So if A transpose is equal to, my A transpose is equal to 1 comma negative 2 comma negative 3, sorry, comma negative 4 and 5. So then my A transpose, because this is a 1 by 1, 2, 3, 4, 5. So this is a 1 by 5. So then the transpose will be a 5 by 1 matrix. So then the original matrix will be 5 by 1 matrix. So I'm not going to put that. We're going to have a 1, a negative 2, a 3, a negative 4, and a 5. Yeah, so this has been your tutor ZM going through a 2017 GCE past paper. There will be a part 2 continuing how to solve the other questions. We'll continue how to solve them. So yeah, please leave a like to the video, subscribe, share with friends, and I'll be seeing you guys in the next video. Thank you very much.